To place man on the moon and safely return him to Earth is a national goal of the people of the United States, recommended by the President and approved by Congress. This is part of the National Aeronautics and Space Administration's major objective, which is to begin the exploration of space and the solar system by man himself. The Marshall Space Flight Center and all centers of NASA and the nation's industrial complex are now working full blast on our manned lunar landing program. Dr. Werner von Braun, Director, Marshall Space Flight Center.
I have always considered President Kennedy's commitment that we are going to put men on the moon in this decade as a kind of signal, an objective very clearly defined, universally understandable, which cannot be debated. Everybody knows what the moon is, what this decade is, and what it means to get some people there and bring them back. It puts the program into focus in a very beautiful, clear, and concise way. Here is the method by which we plan our moon mission.
The Apollo spacecraft will be carried to the moon by the Saturn V vehicle now under development. The three-stage Saturn V, including the spacecraft payload, will stand 350 feet tall, higher than the Capitol at Washington, D.C. It will be capable of carrying about 90,000 pounds from the Earth to the moon. The first stage of the rocket, the S-1C stage, producing 7.5 million pounds thrust, is now under joint development by Boeing Company and the Marshall Center. Its 5 huge engines produce a total horsepower roughly equivalent to a string of automobiles that would reach bumper to bumper across the United States. The second stage of the vehicle, the S-2 stage, is under development by the Space and Information Systems Division of North American Aviation. This liquid hydrogen-fueled stage alone is taller than the Atlas rocket, which was used for the manned orbital flights. It is 3 times the diameter of the Atlas. The third stage, the Saturn S-4B, is under development by Douglas Aircraft Corporation. The single J2 engine of the liquid hydrogen propulsion system will provide 200,000 pounds of thrust. The Saturn V has an instrument unit in the upper end of the S-4 stage, which contains all of the guidance and control instrumentation which keeps the Saturn V on its designated flight path. Above this is the Lunar Excursion Module, the service module containing instrumentation and a propulsion system, and at the top is the Manned Command Module. The use of a lunar landing bug to place man on the moon is necessarily complicated, but it is the preferred method of reaching the moon in the shortest time with the greatest safety for the passengers. When firing time nears, the 3,000-ton monster is erected at the Cape Canaveral spaceport, and enormous amounts of liquid oxygen, kerosene, and liquid hydrogen are pumped into the fuel tanks. After a final checkout, the 3 chosen astronauts are ready for their historic flight to the moon. With the moon and the Earth in the optimum position for the flight, the mighty engines are ignited. The rocket moves ponderously from the launch pad, quickly gaining speed as it rises. Within 2.5 minutes, the first stage has performed its function. After the first stage has burned, it is jettisoned, and the second stage ignited, boosting the speed to more than 12,000 miles per hour. The second stage now drops off, and the third stage ignites, placing the manned upper stages in a parking orbit around the Earth until they reach a point where they are aimed toward the moon. It is now necessary to force liquid fuel to the bottom of the tanks by firing small rockets. The third stage engine reignites, accelerating the 90,000-pound spacecraft toward the moon at 25,000 miles per hour. The metal fairings are next released, freeing the lunar excursion module. The Apollo is turned 180 degrees and connected nose to nose to the bug. With this complete, the S-4 stage is separated and discarded. Now, position calculations are made by the astronauts. With the assistance of computations transmitted from the Earth, mid-course maneuvers are performed to correct the Apollo's course toward the moon. The single rocket engine within the Apollo is ignited when the spacecraft reaches a point about 60 miles above the moon, slowing the craft and allowing it to enter a lunar orbit. Two of the three astronauts now squeeze through the opening between the command module and the bug and enter the bug. The third astronaut remains behind to maintain constant communication with the Earth and with the two moon explorers. During this period, the Apollo and bug are continuing an orbit at an altitude of 60 miles above the surface of the moon. The astronauts examine the moon landing spot and make a final checkout of the equipment. The manned bug changes to an orbit, bringing it closer to the surface of the moon. When it arrives at the closest point to the moon, a blast of its rocket engine slows it enough to allow it to drop from its altitude of 11 miles above the moon. From this point, a landing site is selected. As the astronauts near the surface, rockets fire to permit the bug to hover above its landing spot. If necessary, the spacecraft can be moved 1,000 feet laterally to reach the landing place. With the two passengers in complete control, they still have the capability at this point of blasting off to rejoin the Earth return vehicle if any safety hazards appear. With the decision made to land, the landing legs are extended, and the landing bug is maneuvered to its lunar resting place. The exploration team will remain on the moon for as long as 7 days. They will gather soil and rock samples and will check radiation. Photographs will be taken of surface features and of the heavens as viewed from the moon. Various other scientific investigations and measurements will be made. Only one man at a time leaves the bug. When the explorers are ready to leave the moon, the upper portion of the craft is launched and the lower section left behind. The bug moves up to the orbital path of the main Apollo, which has been circling the moon during the moon exploration. The two vehicles rendezvous and join in the lunar orbit. The passengers transfer to the command module, joining the third astronaut. The three astronauts prepare for the return trip. The bug is separated and discarded, being allowed to continue its moon orbit. The Apollo is accelerated into the return path to Earth. At 250,000 miles from the Earth, the spacecraft is aimed at the proper Earth re-entry path. It must re-enter in a corridor only 40 miles wide. Otherwise, the ship would miss the Earth or crash directly into the Earth, destroying itself by the re-entry heat. Near the Earth, the instrument section is jettisoned. The manned nose section is turned to permit the heat-protected side of the capsule to face the proper direction for re-entry into the Earth's atmosphere. When the spacecraft drops to an altitude of 2 miles above the Earth, parachutes deploy to ease the spacecraft to a safe landing. With the moon explorers safely returned from this greatest adventure of mankind, the way will be cleared for the future, the exploration of the planets.